All right, everybody, this is the 7-3 lesson, the one when we were flipping coins. I'm going to go through the check for understanding on the bottom, the one about potato chips. So go ahead, read the question, pause it, and start it again once you've read the question. Then I'll dive in. We're looking at potato chips, actually potatoes, to see how many of them are blemished. 8% of them is the limit. The proportion of blemished potatoes in the entire shipment. So when you see that word entire, that makes me think that's the population, the entire population, okay? So that this number right here is a parameter. It is the percent of the entire population that is blemished, okay? And then we're going to take a sample of size 500 to see if they're blemished. So calculate the mean and the standard deviation. So we've got that up here in our quick notes. That's these two formulas right here, which I brought down here. The average of the sampling distribution is just P. You may remember up here further up on the notes, we ended up doing, oh, sorry, I don't have it. We ended up doing, it was N times P and then you divided by N, so the N's cancel, so it's just P. And so in this case, it's 0.08. So the average of all these samples that we take, we would expect to be on average 0.08. 8% would be blemished. Here's the standard deviation formula from above. Notice we just use P, that's not P hat, okay? So the standard deviation of the distribution, it's got a little hat there, so it's the distribution, will be this formula, and the formula uses the parameter P. So it's the square root of 0.08 and 1 minus 0.08 divided by n. N's right there, 500. What do we get? Second square root 0.08 times, guess I don't really need that parenthesis, making more work for myself. 1 minus 0.08 divided by 500. Notice how that entire, all of that is underneath one giant square root. So I get 0.0112. So it did say interpret that. So I'll just, I'll start it off and then I won't have space for the rest here. On average, what are we measuring? The proportion of blemished potatoes will, I guess I might write the whole thing, will vary from the mean of 0.08 by 0.012. Okay, so on average, 8% will be blemished, and the variation, on average, it will vary by 0.012 in either direction from 0.08, by about 1.2% in either direction. Number two, justify that it can be approximately normal. That is the large counts. If these are both greater than 10, then you can use a normal distribution to model this. So we call that checking large counts. So the top one is 500 times 0.08, and that is going to be at least 10, so that's 40. The bottom one is likewise going to be big enough, 1 minus 0.08, that would be 460. You might be wondering, like, how did I do that without a calculator? Because these are really just successes and failures out of my batch of 500. So these two numbers have to add up to the sample size. So I knew this was 40, so I just quickly did 500 minus 40 in my head. And both of these are at least 10. So we're good to go. We can, 10 there. We can use the normal distribution. It would be normally distributed. Here's your notation. 0.08 is your average and the standard deviation of 0.012, which helps on the next question. Calculate the probability that at least 11% of the potatoes in the sample are blemished. So here's your normal curve. You can sketch this. This is the setup. If I zoom in so you can see it better, the average is in the middle. And then if you look at this, from here to here, what did I count up by? 0.092 minus 0.08. Oh, look at that. I counted up by the standard deviation. So this is counting by standard deviations. So you can tell right away, 0.11 is what I'm looking for, right? At least 11%, which that would mean I'm finding the probability that the proportion of my sample is at least greater than or equal to 11%. I can tell right away this is going to be small. It's already like 2.5 standard deviations away, and we know from experience there's not much there. So this is not going to be a very likely outcome for a sample. So let's find the z-score. So 0.11 minus, let's see, right here's what I'm doing, folks. P hat is the proportion from the sample. P is the proportion from the entire population. Okay. So I'm taking P hat, 0.11 minus the P, which is 0.08, and I'm dividing by the standard deviation that I just found. 0.11 minus 0.08, well, that's 0.03 divided by 0.012. Oh, look at that. It's exactly 2.5 standard deviations away. At this point, guys, you could look in your green packet. You could look at table A. That's that table with the z-scores. Or you could do your normal CDF button. Remember now what I know is, go away. Oops, don't you all go away. You go over there or something. Is that the z-score in the middle is 0 and this z-score is 2.5, and then the curve keeps going, so I'm going to do 99 for my remember I need my lower and upper boundary on my when I put it into the normal CDF. So I would do 2.5 comma 99. Normal CDF 2.5 comma 99. And look at that. It is not very likely, okay? It's 0.0062. So it's not even a percentage. If you change it to a percentage, it's 0.62%. There is a 0.62% chance of getting a sample where at least 11% of the potatoes are blemished. Not likely at all. All right. Number 4, suppose that your sample finds 11% are blemished. Based on our answer up here, does the data provide evidence, convincing evidence, that the proportion of all potatoes in the entire batch are blemished? So if we got a sample like this, would that be convincing that the whole entire truck of potatoes, the whole shipment of potatoes is bad? The answer is yes, okay? It is so very, very unlikely to get a sample proportion of 0.11. I mean, this is the probability of that happening. You can maybe add that on here. The probability of P hat being greater than or equal to 0.11, I should say, equals 0.0062, exclamation mark. Okay, that is so low, okay? So that convinces me that the proportion of all the potatoes is blemished, that the proportion of all of them is greater than 0.08. It's not likely at all that I would take a sample and get this result if it wasn't reasonable to apply that to the entire population. Okay. There you go. That's it.